Telescopes Part 1. We're going to start by taking a look at some refracting telescopes. Refracting telescopes use lenses, not mirrors. Here's a comparison between refractors on the left and reflectors on the right. A refracting telescope uses lenses, or glass, so the light actually passes through the glass. And one problem with refractors is that as the light passes through the glass, some of the light is lost, absorbed by the glass. Another is that glass lenses can be heavy. With a reflector, the light bounces off, and so it doesn't ever pass through. Some light is lost on reflection as well, but not as much as when the light passes through a glass lens. Also, a mirror can be a very, very thin surface and doesn't have to weigh much at all as long as it's shiny. Another comparison that can be made is that, as you can see here, a refracting telescope has to be quite long. The length of it has to be at least the sum of the focal lengths of the primary and eyepiece lenses. Whereas with a reflector, because the light is bent back and forth, the length can be substantially reduced and the telescope can be much more compact. Right, so this is a simple refracting telescope like the one we have in our room, like the one Miss Sonia brought out for you guys. As you know now, a refracting telescope has its main element here, the objective lens, and then down here is the eyepiece lens. And together, these two lenses focus and magnify the image and enhance the brightness of the image by collecting light. So now let's take a look at some more impressive refracting telescopes from different places. This is the Yerkes refractor at the Yerkes Observatory in Wisconsin in the US. It is, as far as I know, the largest refracting telescope ever built. The primary or objective lens in this case is nearly 1 meter in diameter and weighs several hundred kilograms. To move this telescope somewhere else, the parts that you'd have to move with it are something like 20 tons. So this is huge. You can see the staircase leading up to the axis of this thing, just to give you an idea of how big a person would be in comparison to this. So this is beautiful and brilliant, but of course it's very long and cumbersome and heavy and expensive and difficult. And at this point, reflecting telescopes are definitely the way to go if you want to build huge, super powerful telescopes. And giant refractors are not built like this anymore. Let's look at some of the world's best reflecting telescopes now. If you study astronomy, you get to go to some of the most beautiful places in the world. This is the summit of Mauna Kea, which means the White Mountain in Hawaiian. It's the highest point in the Hawaiian Islands, out in the middle of the Pacific. There's the ocean out there, and you can see the island of Maui in the distance. And the summit of Mauna Kea, because of its cool, even airflow and dry air, and high altitude and dark night skies, has one of the finest collection of optical telescopes in the world. 13 of them or so. Some of the largest ones here are the dual Keck telescopes. Each one has a 10-meter diameter primary mirror. This is the Subaru telescope, and this is the Gemini North telescope. There's also a Gemini South, and each of those has a primary that's just over 8 meters in diameter, and there are many others. There's a huge collaboration of nations involved in this location, nations ranging from the US to Canada to France to Japan, Brazil, Argentina, Peru. So it's just, it's in the middle of nowhere, but it's a beautiful place, and it is a huge international center for astronomy. Another similar place that's not quite as good for astronomy, but no less beautiful if you ask me, is this peak on one of the Canary Islands off the coast of Spain. Another fine collection of astronomical instruments there, dark night skies and thin, cold, high-altitude air. But no matter how high you go on the surface of the Earth, there's always going to be some distortion of what you see out in space because of the atmosphere. And there's a couple of ways to get around that.